So in today's session, we would be talking about a web app which does the optimization in the sense that it allocates the service engineers to the customers on two parameters. First of all, what are the skill sets which are required by the customer? And second, the distance between the customer and the service engineers. So in this specific example, which is a dummy data which I have got, and if you look into this table, these are the different customers: C1, C2, C3, C4, C5. These are the problems which the customers have. So this is essentially a single problem, but it could be decomposed into different components. So the given problem of the customer has an electrical component to it, which requires the scale of 3 out of 5. Similarly, the same problem has the HVAC component, which requires a skill set 1 out of 5, and so on and so forth. Meaning which in the same component, the problem has a plumbing issue, which requires a skill set of 3, and the same issue has a software component as well, which requires the skill set to be 3, right? And these are their locations in terms of latitude and longitude. So this is what the customer data set is, and below if you see, these are the different representatives, right? So these are the different locations of the representatives in terms of latitude and longitude, and the skill of that specific representative in terms of different components, right? So this guy is R1 is trained in electrical HVAC, but not so much in plumbing and not so much in software as well, right? Similarly for R1, R2, R3, R4. So what we are trying to do is optimize the allocation of service representatives to the customers depending on two parameters. First is the geographical distance between the customers and the service representatives, and second, the skill mismatch, right? So, or let's say skill match. So, what we are trying to do is allocate those representatives, service representatives, to the customers wherein there is a least mismatch between the requirement of the customer and the service engineer, right? So, this is the problem statement, and I'll take you through the code in a while. Uh, and then before that, let me also talk about this specific slider. So you can describe or dictate which one do you want to be given more importance. As I talked about, there are two aspects on which the allocation is being done. First is the skill mismatch, and the second is travel time, right? Now, if I give the maximum allocation of weight to the skill mismatch, you see, this is what the allocation which I get. So right now it's saying that R1 should be servicing customer C4, R1 should also be servicing customer C5. I've given the minimum weight to the travel time. Now, just see what happens if I maximize this travel time weight and do something with the skill mismatch. Now, you see this gets changed, right? So, R1 gets to serve C1, and then R3 gets to serve C2, C4, C5. So, it's as dynamic as it can get. Okay. So, now let's go into the code. I won't be taking you through the each and every line of the code which I have, but I will take you to the critical aspects of the code such that you can understand, and if required, yeah, you can reach out to me in case you have any further queries. So this is my GitHub repository. The most critical part of it, I would say, is first of all importing Google Maps. So Google Maps is what I'm using. The API of Google Maps is what I'm using to get the geographical distance and time taken to traverse between two locations. And also I'm using something called as OR tools. Now OR tool is something which is an open source by Google. It is optimization, operation research tools, right? And it is given by Google, and from there I am using something called as a linear solver, because these constraints problem where we try to minimize the weights, right, and optimize the mapping of service engineers to the customer uses something called as linear programming, right? So we are using this. Now, in a separate video, I can show it to you how I am getting the Google Maps API, because the focus over here is to take you through the code, not through the process of getting the Google Maps API per se. And these are the different tenets which I talked about, right? So these are the sliders essentially. So how much weight would you want to be attributed to the skill weight? How much time do you want? How much weight do you want to be attributed to the time perspective? And at the same time, we are also putting a cap on how many maximum customers do we want to be served by a service engineer. No? So in this specific example, we have put it as 3. You could also decrease it as 2. Now, as you decrease it to, this would also change. You see, this has also taken into consideration this particular optimization issue which given to it. All right, so for the time being, let's hide all these functions which we really don't require at the moment. We'll get to it once we reach out to that junction. Now we are initializing Google Maps and we are giving the key which we had given. And we are also reading from this Excel, service.xls, which is, and it consists of customers and representatives in the two tabs. This is what it is, right? So customer and reps, and this is nothing but the same table which I had shown to you earlier, these two tables, customers and representatives. And now what we are trying to do is we are trying to find the travel time. Now this is what this function does, get travel times. So let's look at what does get travel times does. This is the function which first of all zips the latitude and longitude, and then what it does is it finds out this thing, Google Maps.distance matrix. Right, so we pass on the original latitude and longitude in string format to this Google Maps.distance, and it calculates the distance in terms of the time taken to travel from one location to another. And right now I've kept it as mode as driving. Alright, so we get this, and for the times which is unreachable, we make it trip 9999, which means that physically it's not possible, practically it's not possible to reach to that location by driving. Okay, so this is the function, important function, which finds out the travel time being taken. And then what we also do is find out the skill mismatch. Okay, so skill mismatch is again nothing but a way of finding out the difference between what the requirement of a customer is vis-a-vis what the skill matrix of the service engineer is. For example, if we talk about we'll talk about the normalized skill matrix in a bit, but just focus on this table R1 C1. So what is saying is, in terms of the skill required by the customer C1, what is the skill mismatch between R1 and C1? So it is nothing but it would be a difference between 4 minus 3, 5 minus 1, 0 minus 3, because we are talking about plumbing, and then software would be 3 minus 3, so on and so forth. So for each customer versus service engineer, we try to find out the difference between the requirements of the customer versus what the service engineer has to offer. Okay, so we calculate that in a matrix format. Now, the question is, why do we need to have it in a normalized skill mismatch? It's because the travel time, if you see, which we have calculated, is in minutes. So the denomination is in minutes, and over here, this number is absolute. Now, when we are trying to do the optimization, if we don't take into consideration the disparity in the units, we'll get different allocation of weights, right? So, for example, this time matrix, because it would be huge, because it's in minutes, so maybe more weightage would be allocated to it. So, to keep things constant, we make everything linear to remove the denomination aspect. So, we are making everything uniform. So, what we do is we find out the travel time and then divide it by the maximum time, right? So that we get a normal score between 0 to 1. So, just try. This is a way of making everything, every unit, every element between 0 and 1. That's the process of normalization. Okay, so this is the normalized skill mismatch matrix. This is the normalized travel time matrix. And now we take into consideration, we are doing away with the aspect of difference in denominations. Okay, so we do that, and this is the code for doing this. Skill mismatches by maximum skill mismatch. Now comes the interesting part. So till now is more of data sanitization, right? So we got the data from Google Maps, we sanitized it. So right now we have not optimized any which way. Now the fun part starts. So what we are trying to get is something called solver.createSolver, SCIP. So that's the process of getting the tool which does the integer programming for us, right? So we are getting it from PyWRA So it's nothing but a Python wrapper. So Py is for Python, wrap is for wrapper, and LP is for linear programming. So it's a linear programming Python wrapper for linear programming. Okay, we get this, and then what we are trying to do is incorporate the constraints. Okay, so what we are doing is, for example, each customer assigned exactly one rep. So this specific code, what it does is it takes into consideration that each customer should be assigned to exactly one rep. Now, if you want it to be changed to 2 or 3, you would want to change this to 2 or 3, right? So you can play around with this. And then this one, each rep can handle up to maximum customers per rep customers, right? So this maximum using solver.add. Right? So we are adding constraint number one over here, we are adding constraint number two over here, right? And then we say that, okay, objective, use solver.objective. Eventually, we would set it as a minimization because we want to minimize the cost, right? Okay, so interesting. Another part is we talk about I just talked about cost, but how do we calculate this cost? So this cost is calculated by this formula. Okay, so we are saying skill weight, right? Skill weight is nothing but again this specific slider which we got, right? So we are saying that use a weight of 6 in this case and give it to normalization skill mismatch matrix. And for time weight, use the slider which is 10. Right? So now you see more weight would be attributed to the time weight rather than the skill weight. And this is coming straight away from what the user has fed. And over a period of time, if you have loads of data, you can do machine learning to arrive at these weights. These weights need not be given manually, right? You can also train the machine learning models to learn these weights over a period of time. Okay. So we set this objective as set coefficient and eventually we set the parameter as minimization because we want to minimize the cost. Okay. And if so solver.solve would start the process of doing the linear programming for finding the minimum cost. Once it finds that, the status would have solver.optimal, and once the status is solver.optimal, we say that with this